Okay, so I think I should start the class already. So today what we are going to do is doing tutorial on application of Napier's rule. So we learned last week, I think last week we spent quite a lot of time on example 1, so a bit of time on example 2, incomplete, but I sent you a video, you can watch this. So today I'm going to, let's say, tutorial 2 of Napier's rule. I start with a simple example first, right? A simple exercise first. So let's start now, right? With the question. This is I have a right angle triangle now. So I can see the question. Okay, so there's a right angle. So one of the angle is right angle. So very good now. So you can use the spherical triangle ABC. So where is the right angle? Right angle is at angle A, 90 degree. And then remember all the spherical triangle, the side now is measured in degree and radian now. So in degree and minutes are degree, minutes, and second. So in this way, there is a side AB and then angle B. So information are given. Now all you need is draw a triangle. No matter how, it doesn't matter how you draw it. So I'm going to draw it this way at angle A, 90 degree. So I'm going to draw the triangle here now. Angle A, 90 degrees. So I'm going to draw this one. This is my angle A. So it doesn't matter which one is B, which one is BC now. So let's say B is here now. Okay, and then C is somewhere here. So this is my ABC now. Remember, these are the part of a great circle. Okay, great circle, right? So the angle A is 90 degree. Side AB is 46 degree. 90 minutes here. Right, side AB. And side angle B is 34 degree. (28 minutes). And what we are going to do, we are going to solve this spherical triangle. Okay, we are going to solve this spherical triangle. Solve. So the meaning of solve this spherical triangle means find out the rest. Okay, what is angle C? What is AC? What is BC? Okay, so this is what we want. So you label the information in the triangle already. So next is to draw the Napier's field. Okay, Napier's field have a circle. Okay, Napier use a circle to draw Napier fields. You have a circle, and then divide into half. Upper half at 2 sides, lower half at 3 sides, and then divide them equally, and then center your cone. Okay, cone means 90 degree. I'll explain again if you missed the earlier lesson. Okay, so now what you do is angle A is 90 degrees. So this is where you start with. You start with A here, which is 90 degree. Okay, so how do you fill up the information on the Napier's field? So you always go clockwise. Clockwise means this way. Okay, clockwise. Okay, clockwise. And you always go into 90 degree. So that means that this is the first direction, 1. Go into 90 degree, right? From B to A, this is go into 90 degree. So this side is 46 degree 90 minutes. All right, so this side is actually AB here, which is 46 degree 90 minutes, go into 90 degree A. Then from A, second one is here now. Okay, second one is this one, which is AC, right? So you can fill in AC now. What is AC? We don't know, which we're going to find out there. Then it encounter angle C. Okay, so angle C is this one now. So angle C. So encounter angle C now. So you write angle C here. Okay, encounter angle C, go into angle C now, and then this angle C. So then you move on to find CB, right? CB, okay, CB, this one now, 3 now. So CB, we don't know what is CB, so write down just CB only. Then encounter angle B, right? Go into angle B. So this angle B here. And angle B, we are given 34 degree 28 minutes. So this is actually 34 degree 28 minutes here. Okay, so this is how you fill in the Napier's field, right? Clockwise, go into A first, go into 90 degree first, then leave 90 degree, then another one, finally CB. Okay, so far we have two sides there, and two information given to you verbally. All right, so you can make use of this information to find. So the Napier's, how do you apply this Napier views? So you have two side, you have these two here. This is a center. So this is what the center here. So this is center. C is the center now. The middle part. Usually we put the middle part, which are known, but opposite part, you can set opposite part is actually this one now. Okay, so this is actually what we call the middle part. Okay, middle part. Usually we put it as we want to find unknown. Okay, this is the middle part here. Okay, then the green part is the opposite. Opposite the just look at across the opposite part. Okay, from the diagram you can see that the middle part is C, the angle C. Opposite part is side AB and B. The Napier's view, what's the formula of the Napier's view? Okay, let me write down first. Okay, formula for Napier's view, first one, okay, is sine of middle part. Okay, is the product of cosine of opposite. Okay, sine of middle part is the product of opposite. Now, be careful of the middle part here now, okay, because C, angle C is below, okay, below the half circle of a view. So this one, you can write, okay, sine of com. C. Why will you com C? Because angle C is in the below lower part of the view. So that's why you have a com below. Okay. Otherwise, don't need a com there. It's the product of the cosine. So you have this product cosine here. So cosine of what now? There are two things. One AB. AB, you can leave it there because there is upper half of the view. And then cosine of com B now. Why you need com B? Because it is on the lower half of the view. Okay, so there's AB here. And com B, right? Because in the lower half of the view, you must apply the com. And com, what does it mean com? So just remind you, what is meaning of com A, com B? So when you say we are com B, what does it mean? Com B, what does it mean? It means 90 degree minus B. Okay, so what is mean by com C? So this com C here is 90 degree minus C. Okay, this is what they mean. So you can actually use this to do a calculation already. But you can actually simplify it here. What is actually cosine com B, right? Just me right here and write a few things here. What is actually com here? Where we tell you already. Now we can simplify this. So for example, sine of com C. Okay, sine of com C, we have, can you simplify this? You can always simplify this as sine of com C. Last week I mentioned that this is equal to cosine of C straight away. Okay, so that you don't need to press the calculator too many times. Sine of com C is cosine of C. How about cosine of com B now? Okay, cosine of com B is equal to, okay, B is a green color one. So cosine of com B here is actually equal to straight away sine of B. Okay, so you can actually do this simplification. Okay, so that's why I can write this as sine of com C is actually cosine of C now. Cosine of C. Okay, the C is the green color one, that's the middle part here. Okay, cosine of C is equal to cosine of AB now. Okay, cosine AB is actually 46 degree 19 minutes. Maybe I don't write here, don't skip step here so they can see clearer here. So I can write this as AB first, and then cosine of com B is sine B now. Okay, so I have both. All these are okay ready already. Okay, cosine com B is sine B, which I write down the conversion on top there. Okay, these are useful information how to you convert the com. So now cosine AB, you press calculator. Cosine, this is cosine. AB is 46 degrees, 90 minutes. Sine B now is sine. Okay, so instead of combi now is sine now, 34 degrees, 28 minutes. So now you take the product of these two now. Okay, you will get 0.3909. So press the calculator, get 0.3909, and then so C come out now. C is actually cosine inverse, the angle C now. The answer 0.3909 is actually 66.59. Okay, that is the angle C, middle part. Okay, so maybe I can WhatsApp this to you so you can see clearer. So let's see WhatsApp this to you first. All the working. Okay, go to COC now. Okay, anytime you have problem, let me know, right? So let me see any message here. Message here, any message for me? Okay, so now we try to keep as accurate as possible. Okay, so can you round up to 67? We try to say, depend on the situation. So I think the answer in the book, I think give until 66 or something. So we keep it as 66 as accurate as possible. First, two decimal place. So of course you can 67. I think that I have no issue with that. Okay, you can round up to 66, 67 degree. Fine. Okay, fine. This is all right, and no issue with that. This is, I don't think that makes much difference. Okay. So this one I am not going to say until the exam. Maybe you also have two decimal place, then you get two decimal place. Otherwise, you can round up to the nearest integer. Okay. So I think based on the question, okay, the question, because the question give you degree and minutes, two decimal place, right? So we can try to stick to that using the same pattern. Okay. So since you get 46 degree, 90 minutes, so you try to using the same pattern to answer. Okay, maybe this is a better way to judge. Okay, how do you, what kind of answer you expect for the given information. Okay, so I have this already. So let's move to the next one. Next slide here. I'm going to copy this thing and then continue. Edit. Select page now. Copy page here. So I'm going to the next page here. Same. Okay. So you can see the answer given by that, right? So follow the pattern. Okay, so I have find C already. So let me put this information now inside there. So this C now is 66 degree, So I put it in the blue color one. So this is 66 degree, 59 minutes. Okay. So I have, if it is now, it's not opposite side anymore. So, okay, so now let's try to see what can you do now. Okay, their information you can find out what you can find now. You can find AC and CB, right? So you can find AC or CB now. So let's try to find CB now. Okay, so CB now one I want to find out. So you can find AC or CB now. Okay, doesn't matter. So that's why I want to find CB now. So I use a green color for what I want to find. Okay, green color I want to find. Okay, and what did I do? Let's see. Green color, no, not green color. Sorry, I used the green color. I use a what I want to find is a orange color now. Okay, so I use the orange color. Always still the same color, so you know that. Oh, this is actually what I want to find out. Okay, so I want to find CB, and then how do I find CB? I can use the green color now. The green color is the one I integration. This is green color. This is going to call adjacent. Okay, these are called. So this time, the one I want to find is the middle part. So this is middle part now. Okay, now this one is adjacent now. Next to it, okay, that's why I call adjacent. Okay, it's adjacent now. Next to it. Okay, adjacent next to it here. So let me write this. So this is called adjacent. So just now I use a product opposite, like cosine opposite. So now the next Napier's rule is this one. Sine of middle part is a product of tangent. So we use tangent now. Tangent. So I use a black color tangent here. So let's say product of tangent of adjacent. Okay, product of tangent of adjacent. Okay, product of tangent of adjacent now. So let's see how to do this. All right. So now I look at, you know what is meaning a com now. So let's look at how to write it now. So this time CB is a middle part. So but middle part is in the lower view. So this is actually sine of middle part now. So this is equal to sine of middle part in the lower part, right? So it must be com CB. Okay, so com CB as a com there. And then put down our tangent now, right? So now tangent B and C also in the lower part. This one is actually have a com B. This is actually tangent com C. Okay, the reason they have com here because they are in the lower part of the view. Okay, product of tangent. So all of them have com now. So last time I mentioned sine of com is a cosine of com. Okay, sine of com C, cosine com. So this one we have already settled already. So this we know that this is actually cosine now. Cosine of CB now. Okay, don't need count anymore. Just change to cosine. Okay, cosine of CB. Now next one is actually how to do this. You can actually same thing. Com B means 90 minus B. Okay, com B means 90. So you can press the calculator directly. Okay, but you can also save yourself a little bit of work here. Where is tangent com B here? So I will write somewhere here. Tangent com B. What is a com B now? It's a little bit of saving some work here. Tangent com B is as 1 over tangent B. Just 1 over. Okay? 1 over tangent B now. So you can actually use this to simplify. Okay? Tangent com B is 1 over tangent B. Or else you can just 90 minus B. Then you press the calculator. Nothing wrong with that. Okay? So in this case, so I'm going to write tangent com B is actually 1 over tangent B. Okay, tangent com B is 1 over tangent B. Tangent com C is 1 over tangent C.
Wesley, your mic is on.
Okay, so thank you. So 1 over tangent C here. Okay, because I'm using tangent com C. Okay, tangent com C. If I use this, okay, 1 over tangent C. Right? If you don't want to do this, just go ahead, say tangent com B is 90 minus B, right? You press calculator. So now, let's see what is this thing now. This 1 over tangent of 34 degree 28 minute. And then this one is tangent 1 over tangent C now. C is 66 degree 59 minute here. So you press the calculator and see what is this value here. So you'll find that this value is 0.6189. Right, so I use a tangent com B is 1 over tangent B, tangent com C is 1 over tangent C to convert them. Right? If you don't want to convert them, just also use 90 minus B, 90 minus C in calculation. So what is now CB now? So CB, in this case, is the one you want to find out in the middle part. I always use the orange for middle part now. So in this slide here, I use orange for middle part here. So this CB here is a carbon one, and I always use green for the one I know. So I use the I know now is, so this is actually cosine inverse now. You give you And this already 51:47 minutes. Okay, 51:47 minutes. Okay, return the decimal point to 51°47' here. And this is how you find CB. So let me copy this thing to you. So every time you want to do the calculation, you see which part you will need, you can use the orange part to see the, okay, this is what I want to find. So this is called the middle part. Then you decide what are the information can you use now. Okay. So for example, now I can find AC now. Okay. AC is what now is actually find AC already. Okay, so I try to use the same so that I don't need to write so much, all right? So this is CB, I finished already, right? CB, I finished already. So I want to find AC now, right? So I want to copy this whole thing to find AC now. So, okay. All right. So let me erase all these things. I want to find AC now. So this is no longer orange now because I want to find AC now. So AC is the part I want to find now. This is orange. Okay, so how do I find AC? You can use a B and CB. That is product opposite, all right? You can use a product or opposite, but I want to minimize my writing as much as possible. So I'm going to shift the color now. So adjacent, I'm going to shift here. So doesn't mean I cannot use this. I can use this, but I want to shift the green now to here. Okay, so this is adjacent of AC now. So this part becomes adjacent now next to it. Okay, so this is actually adjacent here. Okay, adjacent to AC now. Okay, you can use opposite also, nothing wrong with that. But I just want to save my writing. Okay, so sine of the middle part is equal to product tangent of adjacent. Still the same formula, but only thing, all these change already. Okay, so let me erase all this. So from here, I know sine of middle part. Middle part is our AC now. No need comma. Okay, you don't need any comma there. Okay, Don't need any com. So this is AC here. So this is right. Okay. AC is orange color because I always put them as a middle part. Then I have AB. Okay, now this AB now. So AB. Tangent of AB. Okay, AB don't need com because AB is on the upper half. So this one AB here, you don't need com. However, C you need com because C is in lower half of the view. So tangent com C. Okay, so sine AC, okay, is, so let's see what are information now. Let me fill in the information here because I think this will be useful now. So this one C we find out is 66 degree 59 minutes. Okay, we know C already. We also know CB, right? So CB, we know CB identical right here. So CB with 51:47 minutes here. Okay, 51:47 minutes. So CB is 51:47 minutes now. Okay, 51:47 minutes. All right. So we have all this information already. So this will help us decide later on how what are the information here. So let's try tangent AB. This tangent of 46 degree 19 minutes. Tangent com C, right? Tangent com C is 1 over tangent C now. Tangent com C is 1 over tangent C, which is 1 over. Of course, you can use com C and 90 minus C, but I just want to press less calculation. Tangent com C is 1 over 66 degree 59 minutes here. So we press the calculator. Okay, so we'll give you 0.4448 here. Okay, so what is AC now? AC, we want to find out in the middle part here. Is equal to sine inverse now. Sine inverse of the answer, which is 0.4448 here. So you press the calculator, and then this 26.24 degree, 24 minutes, 26 degree, 24 minutes here. This is the answer for AC. Okay, but when you do sine, always be careful. There's another possible answer. Okay, remember when you do sine of angle, so let me on the next page tell you something about sine function first. Okay, before I press a little bit. For sine theta, right? So this theta here, this is 180 minus theta. So we know that sine theta and sine of 180 minus theta is the same. So in the earlier part, we know sine theta is 0.4448, right? So one possible answer is okay, 0.4448. Okay, if theta equal 26 degree, 24 minutes, we have calculated. Okay, but there's also another answer. It's also theta also, and theta is 180 minus 26 degree, 24 minutes. Okay, so this is another possible answer. Okay, which is actually 153 degree and 36 minutes. Okay, or this one. Okay, so you take 180 minus 24, 26, 24, you get this answer also. But this one is too big already, so there's a possible answer here. So, okay, usually or 180 minus 26 degree, 24 minutes, which is equal to 153 degree, 26 minute, 36 minutes here. So there are two possible answers. Okay, there are two possible answers. Which one is correct now? Remember, the angle and the side are corresponding. That means that if you have a large angle, you have larger opposite side. So for example, AC, okay, AC is opposite angle B. So you can find that AC is opposite angle B. So let me try this one. AC here, AC is opposite angle B. Okay, AC and opposite angle B. How about angle C? Angle C opposite 46. Angle C is opposite 46.19. Opposite degree. So then you find that the bigger the angle, the larger the side. Okay, the bigger the angle, the larger the opposite side. Okay, since we know that the angle is small, 34 degree 28 minutes here, so AC cannot be longer than 46 degree 19 minutes, right? So we reject this one. So that means this answer is rejected. Because AC cannot be so long, right? You can look at the triangle there. Okay, AC cannot be 153 degree 36 minutes because the side of AC corresponds to the angle B. Okay, B is a small angle. C is a large angle. Okay, A is a large angle. A, the side opposite A is 51 degree 47 minutes. So AC cannot be 153 degree 36 minutes, right? So reject. So we know AC is this one. Okay, 26 degree 24 minutes. So this is AC is 26 degree calculated 24 minutes now. You reject the last side here. So this is 26 degree 24 minutes. So from here, we have actually solved the whole triangle now. So let me WhatsApp this to you. Okay, WhatsApp this page to you also as well, since we are actually, where is it now? Yeah, this page here. I think I should tell you this page though, in case you have problem here. That's why I say there are two possible answers whenever you do sine inverse. Okay, whenever you do sine inverse, there are two possible answers. There is tutorial question 1. Okay, so no issue. Okay, now I'm going to move on to do question 3. Right? Question 2, I leave it to you. I'm going to do question 3. All right, question 3 now. Given spherical triangle PZX here, P 82 degree, side P 51 degree 52 minutes, and side Z is 45 degree. Okay, I want to solve this triangle. So solve this triangle. So this is a much harder question now. So solving this triangle, PZX here. So you can try to draw the triangle. I say I'm going to draw the triangle PZX this way first, and afterward I decide. All right. So I'm going to draw P and then Z X here. So a spherical triangle PZX here. Okay. So what is angle P now? Angle P is 82 degree. And then side P means opposite P here. This is 51 degree. This side P here. Side P 51 degree and 52 minutes. And then side Z is opposite Z now. This is 45 degree. Okay, so what is the issue now? Issue now, there is no 90 degree. Okay, so there's no 90 degree. That means you have to create 90 degree now. Okay, and order that means you have two Nepal's view to figure out okay what is the answer. So let's try to do this. I'm going to construct 90 degree here. So question. Okay, construct 90 degree. So I need to give a point name. Okay, let's call this M here. And 90 degree here. Now, some people may ask, why not I try this? and I have a P here, Z here, X here. This is 45 degree. This is 82 degree. This is 51 degree. Can I also do this? Yes, you can do that. But in this case, you do this, you're going to get in trouble. Why is it so? Because what are the information you have now? You only have this triangle, have this information. Okay, this triangle have this information, and the other triangle have this information, and this information is lost. I mean, this information is lost here now. You lost this info. Okay, that means we have one information missing. Cannot tell. Okay, this is your M now. Okay, and we don't know. Okay, then the problem, you know what is PM? You don't know. So, but if you draw a triangle on the left hand side, you have all information there. So one of them is this information. Okay, you know this information. Also, you know this Px here. You know Zx here. So yeah, all three information can be used. Whereas if you draw a triangle this way, you lost one information, right? Because you don't know what is Pm. Okay, you don't know what is Mx here. Whole thing is gone already. So that's why if you draw the triangle carefully, you know, can make use of all three information straight away. Okay, so you have lost one information, you draw this way, but if you divide this way, you can get. Okay, so this is the information I want to tell you. So I WhatsApp this to you first, so that you know why I choose the left hand side, so that you can make use of Napier's view. Okay, so you know that if you use the right hand side, you lost one information already. So now let me erase the left hand side now, because I don't need this. But this one not enough information. You have trouble to get this information here. So I'm going to draw a Napier's view. So let's draw the Napier view. X, M, and P on the left hand side. Triangle PMX first. So let's try the Napier's view for triangle PMX here. Okay, PMX is actually remember using clockwise, right? So I'm using clockwise here. So I'm going to draw an Napier's view clockwise. So upper half got 2 parts, lower half and 3 parts. Okay, for triangle PMX here. So let's try to go in, right? So the angle M is 90 degrees. So if you go this way, so this is how you go in. For PMX now. Right, go into M. PMX, all right? Okay, so the first one is MX here. So MX is actually common side. Then go to M, then get our M now, which is MP now. After going to MP, we enter P now. Okay, P we know, and we know this is actually 82 degree now. Then you go to the third side here, this 3 now. Is Z now, okay? So side Z here. Okay, this is 45 degree. Then angle X, or let's call this X1. We have 2X there. So let's call it X1 here. So this is X1. So the other one X2 lah. So let's call X1 here. Okay, so this is for the triangle PMX on the left side. Okay, so how about the triangle ZMX? Triangle ZMX on the right side now. So X1 is actually the angle. You can write another one. X1 is actually angle XMP. Okay, X1 is triangle XMP lah. If you don't want to use X1, you can XMP is an angle. You can get them. Now let's try for triangle on the right side now. For triangle, so XZM. Okay, triangle XZM now. Again, using clockwise, right? Going to 90 degree. Okay, so let me erase this again. So I use the yellow going to 90 degree M, right? M is 90 degree here. Go into that is actually this one. So I use a different color here. So this is one now. So this is actually ZM. Go inside M. Then get out M. Okay, so this is MX here again. Same MX. Then go into angle X here, but this angle X is actually called X2 now, which is angle, if you write properly, is actually MXZ. Okay, MXZ, angle X2. Then the third one, so I use a different color. And it's strange. Okay, so now this is the way now. This actually accept now. Accept here. It's color here. So this is accept here. Which is 51 degree, 52 minutes here, and then finally go to angle Z. So this is how you draw the Nepal's view. So I can WhatsApp this to you first. You know how I draw the Nepal's view. Okay, so now let's concentrate on the left hand side now. So let me copy, select page first. So this. So I can erase the right hand side first. So I don't need this at the moment, but need space to write down. So how do you find? So information I need to find is, first thing is find out what is MX first. So I use orange color for my middle part. Then I use green color for the opposite part. Okay, so a way you can use to find MX first. MX is the one you can find now. So use a Napier's rules. Okay, let me say how to do like Napier's rules is actually sine of middle is a product of cosine of opposite. Okay, opposite is this thing. So this is the middle. So this is middle here now. These are opposite now. So middle part is on the upper half of circle, so you can just say sine of mx here. Product of cosine, so cosine. Now both of them are in the lower half, so you can should like cosine of com, okay, com p, okay, com p are actually, okay, complete 82 degree. Okay, so com p here, and then com z here, opposite. Z is on the lower half of views, so this is com z here. Okay, we have seen before, com p means 90 minus p. Okay, com p means when you com p here, means 90 minus p. Right? Whenever you have com p means 90 minus p, you can do this. Okay, or you can convert now for cosine. Cosine com p okay, we have seen before, cosine com p is actually sine p. So you can save a bit of work here. So this is sine P. Cosine com Z is sine Z here. Same thing as before. So a bit of information which will help you to do this in the calculation. Okay. Otherwise, you can just press the calculator extra step only. So you put in the information sine 82 degree. Okay, P is 82 degree. Z is 45 degree. So you can find MZ now. Okay, XM now is actually 44 degree 24 minutes. Okay, this is 0.7002. So MX here is sine inverse 0.7002. You get 44 degree 24 minutes here. As I mentioned, whenever I do sine inverse, there are two possible answers, or the other one is 180 minus 44 degree 24 minutes, which is actually 27 minutes. Okay, I think it's 27 minutes. Okay, this one is 27 minutes. Anyway, this is too large. Okay, too large here. One, 3, 5 degree. And 135 degree, all right, is your MX here. Okay, so the largest angle you can see from the diagram is 90 degree for this triangle, right? For this triangle, the largest angle is 90 degree here. So look at this triangle. The largest angle 90 degree, and the side corresponding 90 degree is 45 degree. Okay, so MX cannot be 135 degree. It's too large already. So you reject. Okay, so we know that MX is 44 degree 27 minutes. So these are now MX is 44 degree calculated 44 degree 27 minutes. So this is how we find the MX here. So this is how you solve MX here. So I can WhatsApp this to you. So now, next thing, I have MX settled already. So I can find what are the things you can do now. MX settled. So I don't need this to be yellow part, orange part already. So All right, so let's see what I can do now. I can do MP now, maybe MP should be all right, right? So I'm going to use the opposite again. So I copy this thing. Do the next page now. Okay, so I'm going to use find MP now. Okay, for example, MP, I can put it in the middle part now. And then I can use MP adjacent now. Okay, adjacent now. So I can use this one MP, whatever it is now. This adjacent now. Okay, MP is the middle part, adjacent part. Now, so I can use this thing. I will change the thing now is cosine now, not cosine anymore. Product of tangent. Okay, product of tangent adjacent now. Okay, adjacent is mx and p. So now I don't need this mx I can find now is mp now. Okay, mp is the middle part now. And then the product of tangent, so this two part become tangent now. So tangent of what under mx top, so no con. Okay, on top mx no con. No need con, but p I need con. So this is tangent p now. Com p. So all these have to change already. So no tangent com p is 1 over tangent p now. So I remember just now I have here tangent com p is 1 over tangent p now. All right. So tangent point p is 1 over tangent p here. So we can take this as tangent mx times 1 over tangent p, which is tangent of mx is 44 degree 27 minutes here, divided by tangent of 82 degree. And you find that where is sine mp now. So press the calculator. It's 0.1329, 0.1379. Right, 0.1379. So you can find mp now. Sine inverse mp. In this case, you can sine inverse 1379 is 7 degree 55 minutes. Okay, 7 degree 35 minutes. So there's another possible answer. We'll reject this because obviously this one cannot be too big here. So 7 degrees and then you get 172. Okay, 35 minutes. 25 minutes. 5 minutes here. You reject because this angle cannot be so big, right? MP is the side here. Okay, the side here cannot be more than 44 degrees, right? So it's a very small side here, 7.5, right? So this actually we have 7 degrees and 55 minutes here. Okay, I just want to show you how to find x1 first, and then we can continue tomorrow, right? So actually, x1 first.
Sir, sorry to interrupt.
Which one? Let's see what is the question now. What is the question?
So if I were to find the MP using cosine x times cosine px.
Yes, of course you can do that. Okay, you can use that. I'm just happen to okay. I'm actually okay. If you use a MP, then you have to find cosine. Cosine got a problem there because you don't have x1, right? Cosine you got a problem. Cannot use cosine, right? You don't have x1, angle x1.
Okay, understood.
Okay, so that's why you cannot anyhow use here. Okay, now I'm going to show you how to find x1 now, right? X1 is a lot of choices for you to do now, right? So x1, then I finish off tomorrow, right? Okay. So let me copy this thing here. So I want to find x1 now, so let me erase all these things now. So erase, erase, erase. So I try to keep as much as possible. So I'm going to product or tangent again. Okay, so I'm going to use x1 so that I don't need to write too many things. Okay, so this x1 here. So I will use this one. Okay, so sine of x1 now. So this is x1 now. X1 happen to be xmp. Then I have a mx here, tangent mx here, tangent of com z now. Okay, this is z now. So com z is actually 1 over z now, tangent z now. Okay, then there's a problem there. This one sine z1, right? Sine Z1, be careful. So sine Z1 has a com there. Sine com x1. Because x1 is below the view, right? So the com x1. So this becomes cosine x1 now. So then you put in there. So I know Z is 45 degrees. Everything the same. So I know what is cosine x1 now. Cosine x1 is 0.9810. So that means x1 I can find out is cosine inverse. So cosine inverse has a good point 0.9810. And you're going to get the answer is 11.112. So this angle is 11 degree 12 minutes.
So it's not 78 degrees 48 minutes, man.
Okay. No, why is it 11 degree? Cosine inverse, no? Small
I
angle.
sine inverse just now.
It's not sine inverse. It's not sine inverse now. Now it's cosine inverse, no? Because com x1 is cosine x1 now. Then you get one answer only. So
Oh yeah, so I
sine,
forget to take
okay.
com subtracted.
Yeah.
My bad.
Okay. So what do you do? So I solve the left hand side, right? Tomorrow I will continue in the tutorial session, right? To solve the right hand side. Okay, today is not enough time already. So tomorrow I'll continue. Okay, so I think that will be all for today. Okay, Muhammad Dennis, are you here? Muhammad Dennis, I don't know. Happened. Wait, I don't know. I talk to him. Okay. Okay, that will be all for today. Thank you very much. Tomorrow we'll continue. All right. So I will stop already. Thank you.